Hello everyone, it's Lai Programming here. In today's video, I will show you step by step on how to create this program that you may already see somewhere. So initially we have one ball bouncing inside a spinning circle. One ball come out, we'll create two new balls inside. And to make this program, I'm gonna use Python as the programming language, and I will use a library called Pygame. So to start with this tutorial, even though I will explain everything from scratch, you will have to already know how to install Python and how to install Pygame, which is very easy. You just go to the website, install Python, and then go to the terminal, type in pip install Pygame, and then we can start working on this one together. All we need is less than 80 lines of code, but because there will be some mathematics behind it, I will explain everything again so that absolutely everything you can understand. Step 1 is to use the code that I provided here to create a blank screen program. And every program that you see in Pygame is going to start with this code, which is basically initialize Pygame. In here, I create two variables called width and height, which is the width and height of the program. In here, I create a window. I create the black color because this is the RGB color. Every RGB color will have three numbers ranging from 0 to 255. And then here is the game loops. And these three lines is to handle the events. So we have the click of the mouse or when you press the keyboard. In here, I have the event pygame.quit, which is when I click on button here, it's gonna close the program. Window fill black means we're gonna fill the color of the background with black color. Pygame.display.flip means I update the screen. And then clock.tick 60 mean everything in the game loops will be run 60 times per second. Because we are not dealing with any buttons or any click, I'm gonna leave these three lines alone. And then all we need to do is to add some logics here. For example, drawing the balls, drawing the spinning circle, and then update the coordinate. The next step is to draw the circle and the ball. But first, let's talk about the coordinate of a Pygame program. The origin is gonna start from here. This is the 0, the top left corner. This one is the x-axis. And this one is the y-axis. So this point will be 800. This point will be 800. I want to draw an orange circle at the middle. The center point is this one. Its coordinate will be 400 in the x-axis and 400 in the y-axis. And I want to make the radius 150. And I want to draw the red ball over here. And I want to make it close to the circle. So because this one is already 150, I will make this thing 120. So let's draw this one. First, I will create some new color. So the orange for the circle and the red color for the ball. And I will create the coordinate of the circle center. The circle center, instead of 400, 400, I will make it width divided by 2 and height divided by 2. This one you see the square bracket. That means this thing is the list. Whenever we refer to a point in Pygame, we have to use list. And I will create the circle radius, which is 150, ball radius 5, and the ball position just above the circle center a little bit. I will make it width divided by 2, height divided by 2, minus 120. Let's move to the drawing functions. Underneath the window.fill, I will do pygame.draw, and then I put in the window, the color, which is orange. I need to put in the coordinate of the center of the circle that I want to draw, and then the circle radius, and then 3 is the width of the circle. So let's run this one first. Yes, I will see the orange circle. Next, let's draw the red ball. I will use the same functions, pygame.draw.circle, put in the window, put in the red color, I put in the ball position, and then I put in the ball radius. In here you see number 3, but in here I don't put in anything because the ball is filled in red, whereas this one is not filled. So you see the ball, red ball, and then orange circle. Step number 3 is to make the ball drop by the gravity. The red ball has the x coordinate and it has the y coordinate. So if you want to move the ball down, what you are doing is increasing the y-axis. But the problem is if you increase the y coordinate by a fixed number every frame, that means the ball is going to move down gradually. And that's not how the gravity works. It has to move down faster and faster every time. To demonstrate it, I will create a variable called gravity, and I will update the y coordinate of the ball, which is ball position 1 equal ball position 1 plus the gravity. let's just try this example, and I will make ball gravity become 4. Okay, so every time in the loops, I will increase the ball position, and ball position 1 mean the y-axis because this is a list and the first element start from 0. So ball position 1 will be the second one, which is the y-axis. So let's try this. Okay, you see the ball is moving gradually. We want it to move faster and faster every time. So this is not working, and the way I fix it is to make a ball velocity. I will make it 0, 0. The first number means how it moves in the x-axis, and the second number is how it moves in the y-axis. So if I update the ball position, I can do ball position 0 equal ball position 0 plus the ball velocity 0. And you can shorten this one by using plus equal. So I update the ball position based on the ball velocity. I will make it 1, 1. Okay, so let's say I make it 1. It's gonna move to the right. Okay, you see the ball moving to the right. If I do it like 0, 1, it's gonna move down. And if I do 1, 1, it's gonna move in diagonal. This concept is important because we are gonna deal with vector later on, and we need to understand the component of a vector. Okay, I will make it 0, 0, which is the starting velocity. The way I do the gravity is I add gravity to the ball velocity. Velocity 1 plus equal gravity. So every frame in the game loops, I'm gonna increase the ball velocity. I'll change it back to 0.2. And let's run this one first and see what happened. Okay, you see it dropping faster and faster every time. Okay, how it works is I add the gravity to the velocity. So the velocity in the first frame is 0, 0. The next frame is gonna be 0, 0.2. And then it moved down by 0.2. And then the next frame, the ball velocity become 0.4. So the ball moved down by 0.4. The next step is to make the ball bouncing on the circle. And this is what I consider the most interesting part. All it takes is 4 lines of code, but let me explain the mathematics and the physics behind it. The thing that is responsible for the movement of the ball is the ball velocity vector. And let's say the ball velocity vector is moving in this direction. It touches the circle and it has to bounce back like this. And how it works is it will bounce on the tangent of the circle. Let's say it touched at this point. So the ball is moving down. It has to bounce back. So what it's actually doing is it's bouncing on this tangent vector. And after it touches, the ball velocity will become like this. I will draw it again in here so that it is easier to see. So this is the ball velocity, which is represented in the red vector. And I will divide that vector into 2 components. The first one is the one perpendicular to the tangent. This line is the tangent t. I will divide it into a vector A and another vector called the vector B. And this one is the vector V. I will call the ball velocity is the vector V. This is A and this is the vector B. A is perpendicular to B. After it bounces, it will create a new vector like this. I will call it new V, which is the new velocity. And here's the physics behind it. We have V equal A plus B, and new V, which is the new velocity, will be B minus A. And the reason is that this one is the vector B, and this one would be the vector minus A. Because vector A is pointing down, so negative A is gonna pointing upward. And when we add 2 vectors together, we will take into account the direction of those vectors. So B plus negative A will become the vector new V. From the first equation, I will rewrite it. So A equal V minus B. And I would use this one and then replace it here. So the vector new velocity will become B minus V minus B. Break the bracket, it becomes 2B minus V. V is a vector that we already know, which is the ball velocity. So in order to calculate the new velocity, we need to calculate what is the vector B. And if you look at this, what is B? B is actually the projection of vector V into the tangent. So what we have to do now is calculate the projection of V onto the tangent T. We already know what is V, which is the ball velocity, but we don't know what is T yet, which is the tangent. So how do we calculate the tangent? We will use this vector. I will call this blue one vector D. So now we have D equal the coordinate of the circle center minus the ball position. Let's say after the calculation, this one become X and Y. We can calculate the vector T, which is the tangent of the circle, based on the coordinate of the vector d. So I will just write it right now, and then I will explain it later. So t, which is the tangent, would be negative y, x. The tangent t here is called the normal of vector d. Normal of vector d means every vector that is in the direction that is perpendicular to the vector d. And why the tangent vector t is negative y and x? It is because d is perpendicular to t, so the dot product between d and t is 0, and that's why we get negative y and x. But we need to understand what is dot product. And to understand what is dot product and why dot product of two perpendicular vector is 0, we need to understand the law of cosine. And then I will explain it later, because we need to use that logic to calculate the projection of a vector onto another vector. So in summary, to calculate the new velocity, we have a couple of steps. Step 1 is to calculate the vector d. Step 2 is to calculate the tangent based on the vector d. Step 3 is to calculate the projection of v onto t. And step 4 is to apply the formula that I have here to calculate the final vector new velocity. This 4th step is equivalent to 4 lines of code that I'm going to write later. So now we have 4 steps. Step 1 is to calculate d, which is very easy. And step 2 is to calculate t. And to derive into negative y and x, we need to understand the law of cosine, so that from the law of cosine, I will explain the dot product between two vectors. The law of cosine is like this. Given a triangle with ABC is the length, this angle is alpha, then I will have a² plus b² minus 2 times a times b times cos alpha equals c². But let me prove this one so that absolutely everything I said you can understand. So let's say this triangle is ABC. From C, I will draw CH perpendicular to AB. This one is H. If you look at the triangle AHC, we will have cos alpha equal AH divided by B, which means AH become B times cos alpha. So this one is AH, B cos alpha. AB is A, so we can calculate BH. Okay, so BH equal to A minus AH, which means minus B cos alpha. And if you look at this triangle again, we will have CH is B times sin alpha. So CH equal B times sin alpha. I will apply the Pythagorean theorem on this triangle, which means BH squared plus CH squared becomes C squared. I expand it, I get A² plus B² cos alpha squared minus 2AB times cos alpha plus B² sin alpha squared equals C squared. I will rewrite this equation by grouping B² cos alpha squared and B² sin alpha squared, and then group everything by B². You may be familiar with this, though this one is actually 1. And if this one is 1, then we get A² minus 2AB cos alpha plus B² equals C², which is the thing that we are trying to prove. So why this one is equal to 1? If you have a square triangle like this one is alpha, and the length is ABC. We have sin alpha is A divided by C, and we have cos alpha is B divided by C. So you square it up. And if you add these things together, then it means this one plus this one. And A² plus B² is actually C², according to the Pythagorean theorem. Now that we know the law of cosine, let's apply this one into vectors, and that will explain what does it mean by dot product. Let's say I have two vectors, which is A, and I have another vector called vector B. So if I connect them, this one would be vector B minus vector A. And let's say this angle is alpha. I will apply the law of cosine above in this triangle. Because this one is the vector A, I will need to use the length of the vector A when I use the law of cosine. So if I rewrite it, it would be the length of vector A square plus the length of vector B square. This is the symbol for the length of vector. Then minus 2 times the length of vector A times the length of vector B times cos alpha will be equal to the length of vector B minus the A square. Next step is I will put this one to the right hand side. I put this one to the left. And by definition, this one is called the dot product of A and B. You can write it A dot B. This one is the dot product. The next step is I will simplify this one in terms of coordinate. Let's say the vector B has the coordinate b1, b2. And let's say the vector A has the coordinate a1 and a2. So the vector B minus vector A, the coordinate of that vector will be b1 minus a1 and b2 minus a2. And the length of the vector B, I can calculate it as square root of b1 square plus b2 square. And let me explain quickly why is that. Let's say this one is the vector B and it has the coordinate b1 over here and b2 over here. This one is 0. So b1 square is this one square, b2 square is this one. b1 square plus b2 square would become this vector B square, which is the length of the vector B square. So that's why I need to take the square root. Similarly, I can have the length of vector A is square root of a1 square plus a2 square, and the length of vector B minus vector A would become the square root of b1 minus a1 square plus b2 minus a2 square. This one is also called the norm of vector B, or some people say the length of vector B, or you can say the magnitude of vector B. Anyway is correct. Okay, so now we replace all of that, all of this thing, into the equation I have over here. So this one will become a1 square plus a2 square plus b1 square plus b2 square minus b1 minus a1 square minus b2 minus a2 square. All of that divided by 2. And I want to do it quickly here. So if I break the bracket, this one will become a1 square minus 2a1 b1 plus b1 square. And a1 square will eliminate that a1 square over here. And b1 square will eliminate with this b1. b2 square will eliminate that. And a2 square will eliminate that. So at the end, I will have a1 b1 plus a2 b2. And this is how they get the dot product of two vectors. So let's say you have vector A, which is a1 a2. Vector B is b1 b2. Then the dot product of two vectors will be a1 times b1 plus a2 times b2. So let's say the vector A is perpendicular to vector B. Then that means if this one is A, this one is B, and this is the alpha. If alpha become 90 degrees, then A will be smaller and smaller. So eventually A will become 0, which means cos of 90 degrees will be 0. That's why if I take the dot product of two perpendicular vectors, the value would be 0. And just keep in mind that the reason is in the dot product, we have cos alpha and cos 90 degrees is 0. Okay, so from this one, you can get a1 b1 equal negative a2 b2, which means b1 divided by b2 equal to negative a2 divided by a1. Okay, now look at this. We have A is a1 a2. The vector B that is perpendicular to it would be negative a2 and a1, which is why I have over here, I have if the D vector is x and y, the direction vector, then the tangent, which is the normal vector, the one perpendicular to it, it would be negative y and x. And I just proved that using the law of cosine and the dot product over here. And the next step is to calculate the projection of a vector onto another vector. But now that we understand all the fundamental, that things will be very easy. The projection of A onto B would be the vector P that I indicate in red over here. So the vector in red is the projection, and P is the projection of A onto B. And the vector P, we can say it is equal to the length of vector P times the unit vector B. Okay, what does that mean? B hat, this one is called the unit vector. So if I have B, that means the vector B. But if I write it as B hat, that means it's the unit vector. And the unit vector means a vector that has the same direction as the vector B, but the length is 1. But let me explain this part again. So this one is a scalar. It's not a vector. It's the length of the vector P. Or you can say the magnitude of P. Or you can say the norm of P. Or you can say the length of P. This one is multiplications. This is not a dot product. And this one is the unit vector B. Okay, now I will explain this part again. It may be non-intuitive for some people. So P is a vector. I take a vector and then I multiply its magnitude. So I take the direction of a vector. So this is the direction of P, and this one is the length of P. And if I multiply them together, the magnitude and the direction, it will become the vector P. Why this one is the unit vector instead of the vector B? Okay, so if this one is B, then let's say it is this vector, and then I multiply it with this length, so it becomes a much bigger vector, which is not correct. I will make this angle alpha. So the length of vector P, which is this length, which is a number, not a vector, is the length of vector A times cos alpha. So I will rewrite the equation of vector P equal to the length of vector A times cos alpha. Okay, so this part is equal to this part. Now, how do I calculate the unit vector B? You can do it by using the vector B divided by the length of vector B. So the vector itself divided by its length will become a unit vector. That unit is length 1, and it has the same direction as the vector B. Now, how do we calculate the cos alpha? And here is where the dot products comes in. So over here, I already show you that the dot product of two vectors is the length of A times the length of B times cos alpha. So cos alpha would be the dot product of A and B divided by the length of A and divided by the length of B. So I'm going to rewrite that. So this one will be equal to length of A times dot product of A and B, A dot B, divided by the length of A times the length of B, and then times the vector B divided by the length of the vector B. Okay, so cos alpha equal to this part. Now you see the length of vector A here can eliminate the length of vector A here. So at the end, it becomes the dot product of A and B divided by the length of B squared times the vector B. So I will rewrite it. A dot B, this is the dot product, not multiplications, divided by the length of vector B squared times vector B. This one is a number, this one is a vector. So numbers times vector become a vectors. The last thing I want to show you is we can transform this one, the length of vector B squared, into the dot product of vector B and vector B. So if I have vector B is B1, B2, then I know that the length of vector B square is B1 squared times B2 squared, right? But what is the dot product of B and B? The dot product would be, so B1, B2, and then the dot product of that vector by itself, B1, B2, and according to the formula, A dot B become A1, B1 plus A2, B2. So if I use the dot product of these two vectors, it will become B1 times B1 plus B2 times B2. So it will become B1 square plus B2 square. So finally, I can rewrite this one. The projection will eventually become the dot product of A and B divided by the dot product of B and B times the vector B. Okay, now come back to our main problem, which is the bouncing physics. Okay, so step 1, calculate D. We've done that. Step 2 is calculate the tangent. And then once we know what is D, we know what is T. And V is already the ball velocity, which we already know. T is what we already know, which is negative y and x. You can calculate the projection of V onto T, which is something like this. I'm going to rewrite it. So projection of V onto T, according to the formula, will be dot product of V and T divided by dot product of T and T times the vector T. So you can calculate this one, which means you can calculate the vector B over here, which is the projection. And step 4 is to calculate the new velocity, which is how the ball is going to bounce. Now we go to the most fun parts, which is using 4 lines of code to represent these 4 steps. And you will see the ball bouncing on the circle. In the previous step, I've made the ball falling using the gravity. And the next step would be step number 4, adding the bouncing effect, which is calculating the new ball velocity using the 4-step formula that I have described and proved before. But first, we need to check when the ball touches the circle, so that at that point, we are gonna use the formula to calculate the new ball velocity. To do it, I will check the distance between the ball and the center. So let's say this is the ball. I will calculate the distance between the circle center and the center of the ball. I will call this one dist. So I will take this and then I add it with the radius of the ball, which is ball radius. When the ball is inside the circle, this sum will be smaller than the circle radius. And this is the circle radius. Okay, let's take another example. Let's say the ball is already outside. This would be the dist. And this white line is the ball radius. And you can obviously see that the distance is greater than the circle radius. Now let's say the ball is just touches the circle like this. This would be the distance. And here is the ball radius. At this position, the distance would still greater than the radius of the circle. So that means the ball is already out. And the reason why we cannot use the equal sign in here is because the ball will never touch this exact position. Because every frame it will move slightly. Every frame it will move like this. And then if we move out of the ball, it will never touch the ball. Of course it can touch, but it's very rare because we are dealing with float number. Now to calculate the distance between 2 points, I'm gonna use a library called NumPy, and you have to install it. Pip install NumPy. This library is gonna help us deal with vectors, how to calculate the norm of vectors, which is the distance between 2 points. It will also help us calculate the dot product easier. So first I import NumPy. So import NumPy as NP. So I can use NP instead of NumPy. And in here, after I update the gravity, I will calculate the distance. This will be the distance between the circle center and the ball radius. And in NumPy, you can easily do that by using np.linearalgebra.norm. So norm is the magnitude, or you can say the length of a vector. So ball position is a point, which is a list that have 2 numbers. Circle center is another point. So this one minus this one, calculate the NumPy norms, which is the root of the sum of square. But before I do this, I need to convert ball position and circle center into NumPy array, because in here is still a list. So I will do it by using np.array. And I also need to specify the data type. dtype equal np.float64. This step is really important because if you don't have that, then the data type would be integer and all the number will be rounded up. Not only that, because the gravity is 0.2. So let's say the position is 0. You add 0 with 0.2, which is 0.2. And if the data type is integer, then 0.2 will become 0. So the ball will never move. And similarly, I want to change the ball position to a NumPy array, so I can do these calculation easier. So I add the same thing and I add the data type as well. Make sure the D type is float64. And we need to change the ball velocity as well. So convert this one into NumPy array and make sure you specify the data type, make it D type float64. So now every point, every vectors, the ball velocity is the NumPy array. Now I can calculate the distance, which is equal to the norm of this vector. This vector is the vector connecting between the ball position and the circle center. This one is the distance. And now I can add the logic that I described before. If the distance plus the ball radius is greater than the circle radius, that means at that position, the ball is already out. I'm going to test it. Okay, now it print nothing and then you can see out, which means it's working properly. Now test this one more time. Have a look at this. It's printing nothing. Boom. It's working. Now let's add the bouncing effect that we have discussed before. So step 1 is to calculate the vector D, which is the direction. D will be the vector between the circle center and the ball position. So I will take the coordinate of one point minus the other. Inside the if statement, to check when the ball is out, I will do D, which is the vector D, equal ball position minus circle center. After that, we calculate the tangent T, and in here I say that if D is X and Y, then T is negative Y and X, which means in here T will be negative D1 and X, which is D0. And I need to put this into NumPy array because this one is a vector. So NP array like this, put this in a square bracket and make sure to add the D type equal to numpy.float64 to. Next step is to calculate the projection of V onto T. So the first step is the dot product of V and T. I will do projection of V onto T equal. I will calculate the dot product first, and in NumPy you can do NP dot and then put in the two array. So V and T, the V is the ball velocity and the T is T, divided by the dot product of T and T. So NP dot and then T and T, all of that multiplied by the vector t. So this dot product is a number. This dot product is a number. I take all of that, put that in bracket, multiply by the vector t. And the last step is to calculate the new velocity. So ball velocity will become 2 times the projections and then minus ball velocity. Let's test it. Okay, I run it. Cool. Now we can see the ball is bouncing on the circle. Now let's do some other tests. Instead of making the ball move down in a straight line, I'm gonna adjust some initial value of ball velocity, 20 and 30. We can see sometimes the ball is moving out of the circle. And the reason for that is, suppose the ball is in this position, which is still inside the circle, because it is moving very fast. So the next frame, it would be outside of the circle. That is the jump between one frame to another frame because the velocity is high. If we don't want to draw the ball when it's out, we have to adjust the ball position. So let's say the ball is here, we have to make it here, which is the position where it just touched the circle, but it's still in the same direction. To calculate the ball at this position, I would take the direction vector, which is connecting from the center and the ball center. This one is previously known as the vector d. I would calculate the d unit, which is the vector that has the same direction as the d, and the length is 1. Remember, our goal is to calculate this point. So I would take the d unit multiplied by this distance. And this distance can be calculated as the circle radius minus the ball radius. In here, I already have the vector d, so I have to calculate the unit vector d. And I do that by taking the vector d divided by its length. And to calculate the length of a vector, in NumPy, you can do numpy.linearalgebra.norm, put in the d. After that, I will update the ball position, which is the circle center, and how it moves away from the circle center, which is the circle radius minus the ball radius multiplied by the unit vector. And let's test it again. Let's try to make it 50-50. So it's moving very fast. Now we can see that no matter how fast the ball moves, it will not go out of the circle. Another thing is because I have changed everything to NumPy array over here. So what I can do is I can shorten these 2 lines of code. So instead of just adding to the x coordinate and then adding to the y coordinate, what I can do is I can take the whole vector, which is ball position, plus equal ball velocity. We cannot add 2 lists together, but because this one is NumPy array, we can do that. In the previous step, I've added the bouncing effect to the ball. And in this step number 5, I'm gonna add the spinning arc, which is this missing part of the circle. And not only that, because the circle is spinning, it will have to add some force to the ball as well. And that one is called tangential force. I'm gonna make it move slower so we can see what's going on. So this is the ball dropping in straight line. And instead of bouncing upward, it will bounce to the left. Let me run it one more time. So it's dropping straight and then move to the left because the circle is spinning. To do it, I will first create some new variable. Arc degree equals 60 degree. And I have start angle and I have end angle. And I have to convert that into radian. And I also import the math library. This one is a built-in library in Python, so you don't have to install it. And let me explain these 3 variables. Let's say the arc that I want to draw is alpha, which is this one. And in here, I specified as 60 degree. So I will need a start angle and an end angle. The start one, I will make it over here, which is 30 degree. And then the end angle would be 30 degree over here. So this one is the start and this one is the end. And instead of degree, I have to convert that into radian because the sin and the cos will be calculated in radian. And the way I draw the arc is by drawing a triangle like this. So I will have a triangle. This one would be drawn on top of the circle and the color is black. So it looks like the arc is missing from the circle and it looks like the circle is spinning if I change the start angle and the end angle every frame. And to draw a triangle like this in Pygame, you need to have the coordinate of 3 points, which is the 3 vertex. Let's say we want to draw this point and we know the angle is alpha, and because the circle radius we already know is r, then we can calculate this distance would be r times cos alpha. So the coordinate of this point would be x plus r times cos alpha. And similarly, look at this square triangle. This would be r times sin alpha. So the y coordinate of this one would be y plus r times sin alpha. So I will create a new function called drawArc, which is taking in window, the center coordinate, the radius, start angle, and end angle. And this one is exactly the math that I described over here. And this function draw polygon is going to draw a triangle between these 3 points. Let's say I draw this one in red and I want to draw it right after I draw the circle. So here is where I draw the circle. I will call the function drawArc at the start angle and end angle. So let's run it first to see what happened. Okay, here is what it looks like. It is not spinning right now because we don't update the start and the end angle, but the degree between them is 60 degrees. Now I want to make the arc spinning. I have to update the start angle and the end angle. Let's say the angular velocity is 0.01, and I will update the start angle and the end angle. So at the start of the game loops, I'm gonna update the angle. Start angle plus equal spinning speed, and end angle plus equal spinning speed. So let's run this one again. Okay, you can see it's moving. Now if I make the triangle a little bit bigger, it will cover an arc of the circle. To make the arc bigger, I will need to come back to the functions. Instead of radius, I will add in a really big number, which is, let's say, 1000 plus 1000. And let's test again. Okay, now it's much bigger. Now I change that color to black. Okay, instead of red, I will say black. Run it again. Okay, it is spinning right now. And make sure that the triangle that you draw is between the circle and still underneath the ball. Otherwise, the ball is going to disappear. And now the next step is I will add the tangential force so that the spinning circle can drag the ball as well when it touches. To do it, I will scroll down to the game loops. And here is the logic when the ball touches the circle. Here is the new ball velocity. I will need to add something new to the ball velocity. So ball velocity plus equal t times the spinning speed. This one is called the tangential force. And the formula for this one is v equal w times r. W is the angular velocity, which is spinning speed in this case. And r is the radius of the spinning circle. So the bigger the circle, the larger the force. And here I use the vector t because t is the tangent, which we already calculate. And not only that, because of the way we calculate the vector t, which is in here, it already contains the information of the radius. Now let's test it. Okay, it's dropping straight and then it's moved to the left. And the next step is to make the ball dropping out of the circle when it touches the arc. And to do that, we need to calculate the angle of the ball. Let's say this one is the ball position and this is the circle center. The angle that I need to calculate is the blue one alpha over there. So to do that, you will need to calculate a couple of distances. That's the first one, which is the distance between the x coordinate of the ball and the x coordinate of the circle center. And I call this one dx. And similarly, I will need to calculate dy. This one is the dy. So now tan alpha would be this distance divided by this distance, which is equal to dy over dx. And from that, I can reverse it and calculate the alpha. So in the code, I will create a new function called isBallInArc. This function will take in the ball position, the circle center position, the start and end angle. After that, I create the dx and dy, and then I do the reverse tan to create the ball angle. After that, I check if the ball angle is between the start and the end angle. If this one is true, then I will return true, which means the ball is inside the arc, which means it will not bounce. After that, in the main program, I'm gonna create a new variable called isBallIn. This one is the state of the ball, so it is either out or in. And my logic is when the ball is out, we consider it's out, so we don't add any bouncing effect to it. So initially, the ball state is true. So scroll down a little bit. After I check if the ball is already out, I'm gonna add a condition here, which is checking if the ball is in arc. If it is in, then that means we will let it free fall, which means I will change the ball state, which is isBallIn, the new variable that I just created before. This one will become false. After that, I will add a if statement. If this one is equal to true, then I'm gonna add the bouncing effect. Let's test it. Okay, it's bouncing and then it should go out. But then when I test it with other coordinate, other ball position and other velocity, I found out that in some position, which is for example in this area, it will bounce off even though it should not. And the problem is I will need to change the logic of this function a little bit, Because the start angle and the end angle increase every time, I want to normalize the values so that it always stay between 0 and 2 pi. So first, I normalize the start angle, and after that, I normalize the end angle. After that, I need to check if the start angle is greater than the end angle, then I will add 2 pi to it to make sure that the end angle is always greater than the start angle. And also in the if statement, I need to add an additional statement. I need to check that if the ball angle plus 2 pi is between the range also. And now it's gonna work. When I add more balls into it and you try to remove this part, you will see why do we need this one. Now that the ball can fall out of the circle, I'm gonna add the last step, which is adding the logic so that one ball come out will create 2 new balls inside. One way to do it is to create a list with many ball position and ball velocity and then looping through the list, but that way is not very efficient. And what I'm gonna do is I'm gonna create a new class called class ball. This class will take in the position and the velocity, and this class will have 4 attributes. The first one is the position. I will convert the position into a NumPy array. It has the velocity, it has the color. Each color will be a random color. And then the last attribute is in, means whether the ball is inside the circle or not. Scroll down a little bit when I initiate those variables. Instead of having a ball position and a ball velocity, I will create a ball which is the list of ball, and then initially there will be one ball inside, and the ball inside will be ball, and then I put in the initial ball position, and then I put in the initial ball velocity. And because the ball has the isIn attribute, which is always true at the start, that way I can simply remove this variable. Now coming to the main loop, instead of doing all of this logic for one ball, I'm gonna have a loop called for ball in balls. That way it will loop through every ball in the list, and then I tap this to make it inside the for loop. And instead of ball velocity here, 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 and here, I'm gonna replace all of that with ball.v, which is the velocity of the ball. Next up is the ball position. I have here, here, ball position, ball position. I'm gonna replace all of that with ball.position, which is the attribute of the class. And finally, instead of using this variable is ball in, I'm gonna replace it with ball.isIn. And before I do all of this logic, I want to check if the ball has already fallen out of the circle or not. So the logic is when the ball falls out of the screen, I'm gonna remove that ball and then add 2 new random balls into the list of balls. And here is the logic that I would use. I will check if the ball position is greater than the height or is smaller than 0, which means it's falling out of the screen. If this happens, then I will remove the ball from the list of balls, and I can do that by balls.remove and then ball. After that, I'm gonna create 2 new balls inside. The 2 new balls that I create will have the similar initial locations. And then I will make the velocity become a random number. Now the last thing that we need to fix is when we draw the actual balls. So scrolling down, when I draw the balls over here, in here, instead of drawing one ball with the red color, I will add a for loops to it. So for ball in balls, I will draw a circle, but the color is not red. The color will be ball.color. The position is not ball post. The position will be ball.post, and the ball radius is still the same. Now let's test everything. Okay, I have an error because I use the random functions here. I need to import the random. Now run it again. So now when a ball coming out of the screen, 2 new balls will be created. If you have made it to this point, thank you so much for watching. And there are so many extensions that we can do for this one. For example, you can add some new sounds to it. You can change the color. You can add some of the keyboard button that we can, for example, expand the circle center, expand the ball, stop the ball, or you can try making the ball collide with each other. And in this video, I haven't added any sound, so you can add some sound effect as well. If you don't understand anything in the video, please leave a comment below and I will try to answer them. This one is the first video of my channel, Lai Programming. This channel will be for beginner want to learn how to program, and I will focus on Python mainly because my experience is mostly Python. Thank you so much. I am Lai Programming.